Hey everyone, in this lesson we're going to cover probability. This is the first lesson in our probability unit. We're going to be focusing on single event probability, which is basic, simple probability. It's more of a review of things that you've learned in the past. It's kind of common sense stuff, but there is some notation things that we want to cover as we go through this. Before we begin, go ahead and do these warm-ups. Now warm-ups are going to look different than we would do normally in class, because we don't have the ability to really grade and input and all that stuff, at least not in this setting of a video. So what I want you to do is do the warm-up, and then I'm going to quickly go over it. I mean really quickly go over it. Check your answers, make sure you understand the concepts, because a lot of times the warm-ups are review problems from prior units and practice problems from this unit, so that should help you moving forward into the unit test and finals and whatever else is going on. But if you're getting them wrong and you don't know what you did wrong, please make sure you're asking me for help during office hours or something along that line. All right, so go ahead and pause the video and try number 1 and number 2, and then push play when you are ready. For number 1, the volume of a rectangular prism is given by a polynomial expression. What could the dimensions be? Well, remember, the volume of a rectangular prism is length times width times height. And so if we can get three things that are multiplied together to equal 5x cubed plus 15x squared minus 140x, then we know each of those things is a factor, which means each of those things would be a dimension. So we're going to factor this guy. Remember, when we factor a polynomial, the very first thing we look for is GCFs. So the GCF here is 5x, and we're left with x squared plus 3x minus 28. And then we do our quadratic factoring, which produces x plus 7 and x minus 4. So we can say our length is 5x, our width is x plus 7, and our height is x minus 4. It doesn't matter which order you put those in. You could call the length one of the others, width one of the others, and so on. But those are the three results. For number 2, it says solve. Now, we have multiple methods to solve this. We could solve by completing the square, we could solve by factoring, we could solve by quadratic formula. For me personally, factoring is always the best method as long as factoring works. And a quick look at this, we can see that factoring does in fact work. The factors here are going to be x plus 6 and x minus 4. Then we use our zero product property, so we set each of those factors equal to 0. And then we solve for x, so our answers are negative 6 and 4. So that's the warm-ups. Let's go ahead and go on to the lesson. Now what I want you to do is take notes like you normally would in class. You've got your title, your objective, so write that as an essential question, and then take notes like you normally would. So if it's a practice problem or if it's a discovery type of thing, put it on the left hand side. If it's concrete notes, I want you to put it on the right hand side. Sometimes you'll just have to use your discretion on which side it can go on, because you don't have the ability right here, right now to ask which side should I put this on. Just think through it and do what you think is best. All right, so the goal here is to be able to determine the probability that an event will occur. Well, we have some terminology that we're going to have to go through to understand what that's saying. And I know we understand for the most part what that means, but we want to make sure that we know the terms, because this is the first lesson, and that's what we're going to go through, is the vocabulary a little bit. But before we do that, let's go ahead and look at an example of what this looks like. If I had a 6-sided die, just a regular die that I would play in Monopoly or some other board game, and I roll it. So I have one die and I'm rolling it. How many possible outcomes are there? Well, obviously you could land on 6 different outcomes, 1 through 6. Okay. What are the possible outcomes? So here we're going to list the possible outcomes. So there are 6 of them. What are they? Well, obviously the 6 things you can get are 1, 2, 3, 4, 5, and 6. But the way we write that is we put it into a set notation. So we put the little squiggly thing on the front and we write down all the possible outcomes, and then we close it with a closed squiggly, right? So 1, 2, 3, 4, 5, 6. This is what's called the sample space. These are all the possible outcomes that you can get out when you roll a die. And this is a standard thing. We always want to use this notation in writing out all of the events, all of the things that are possible in our sample space. All right, so for part C, it says, what is the probability that it lands on 4? What is the probability it lands on 4? Well, that's pretty easy. How many times does it land on 4? Well, it only lands on 4 one time. and there are 6 possible outcomes. So I like writing the spaces out. This is called the sample space. The bottom is a sample space, and the top is what's called the event space. So we list all the things that we want on top, and then we list all the things that we could possibly get on the bottom. So we want a 4 out, and we could get any one of these 6 things on the bottom. So our probability is 1 out of 6 because we're just counting how many things on top and how many things on the bottom. For part D, it says, what is the probability that it lands on an even number? Well, that's pretty easy. Which ones are the even numbers? Well, the even numbers are 2, 4, and 6. So those are known as our event space. The event is the thing that I want to have happen. The sample space is all the possible things that can happen. So obviously, the thing on the bottom is always going to have more things in it. The space on the bottom is always going to have more things in it than the space on the top, because these are all the possible outcomes. And then the things on the top, the numerator, is all the things that we want to have happen. So those are obviously going to be less things than the bottom. I guess it could be equal to. But if you think of it this way, also, simplifying this or counting, we get 3/6 or 1/2. This fraction can never be greater than 1. You can never have more things that you want to have happen than the possible things that can happen. So our event space must always be smaller than our sample space. For part E, it says, what is the probability that it lands on a number greater than 4? So now we have to find the things that are greater than 4. Well, looking at our sample space, we have 2 things that are greater than 4. That's 5 and 6. So we're going to list them out as our event space. And then obviously on the bottom, the denominator, we're going to put our sample space. So how many things on top? 2. How many things on the bottom? 6. And as a result of that, we can reduce that and get 1/3. So that's kind of an exploring type of thing. Hopefully that's pretty straightforward. But I just want you to make sure that you're using the notation that we're talking about here, using the set notation is what it's called. Let's go ahead and go on to the actual definition of probability. Now, probability of an event is how likely it is for that event to happen or occur out of all the possible outcomes. So how likely can something happen out of all the various outcomes that do happen? So we write it like this in mathematical notation, if you would. Okay? And we'll see more of this in the future. The probability of an event is equal to the number of outcomes within the event divided by the number of outcomes within the sample space. So we say probability P of, right, like f of x kind of, P of whatever we want here is equal to how many times what we want can occur over how many different options there are. So there's the event space and then there's the sample space. It's always, the probability is always the event, the number of things in the event divided by the number of things in the sample space. All right, so here's an example of this, pretty straightforward. We have here a few doors. So we have 5 doors, and it says behind each door is a prize ranging in value from $100 to $500 in increments of $100. What is the probability that a contestant wins more than $300 by picking one door? So we have 5 different options ranging from $100 to $500. So behind one of these doors is $100. Behind one of these doors is $200. Behind one of these doors is $300. Another one is $400. Another one is $500. And so basically you're going to win a prize no matter what door you pick. It says, what is the probability that a contestant wins more than $300? Well, we would say the probability of $300, so if we're going to write it in this form, we'd say P of $300 equals, but from here let's list out the things that are in the event space, the things that I want to have happen. So I want to get more than $300. Well, the 2 options here are $400 and $500, so more than $300. So the possible event outcomes are $400 and $500. Notice I write it in set notation. Now, what are all the possible outcomes? What is the sample space? Well, the sample space is all of them. We could get 100, we could get 200, 300, 400, or $500. So how many things are possible? There are 5 things that are possible. And how many of those things am I trying to get? I'm trying to get 2 of them. So we'd say the probability of more than $300, not probability of 300, but the probability of more than 300 is going to be 2 out of 5. Now, before we go on, there are 3 different ways that you can write an answer for a probability. You can write it as a reduced fraction, so 2 out of 5. You could write it as a decimal, so if you just type this into your calculator, or if you already know it, this is 0.4, just 0.4. Or we could write it as a percentage. So because 2/5 is 0.4, the percentage that's equivalent to 0.4 is 40%. Okay, so keep that in mind. There are 3 ways to express your answers when you're talking about probability. A fraction, a reduced fraction, a decimal, and it will say round to the nearest whatever. Remember, if it doesn't say round to the nearest whatever, then you round to the nearest thousandth. That's the standard. And then the percent, so you would just write it as a percentage if it asks for that form. All right, going on here, here's a practice problem. So what I want you to do is pause the video and try and do this on your own. And then when you are done doing this, push play on the video and see how you are doing. For this problem, it says there are 4 red rocks, 3 blue rocks, 2 red marbles, and 1 blue marble in a bag. One item is randomly selected from the bag. So we're reaching our hand in the bag and we're not feeling around to see, oh, is this a rock or a marble? We're just grabbing the first thing that we come across here. What is the probability that the object is red? Well, we're going to list out our event space and our sample space. So all the possible event outcomes, so all the things that I want to have happen, well, I want it to be red. Well, that happens because I have 4 red rocks and I have 2 red marbles. So that's my event space. My sample space is everything. So if you were to simplify this, you would say that you have 7 rocks and 3 marbles. But the bottom line is, how many red things do I have? I have 6 red things. And how many things do I have altogether? I have 10 things altogether. So the probability of something being red is 6 out of 10, and that can reduce to 3/5. Number 2, it says, what is the probability of the thing being blue? Well, the blue things are, the event outcomes are 3 blue rocks and 1 blue marble. And then again, the sample space is going to stay the same, 7 rocks and 3 marbles. And so how many things are in my event space? Well, I have 4 things in my event space, and I have 10 things in my sample space, and that reduces to 2/5. Now notice, I think this is kind of cool. We're going to talk about this more on the next slide, I believe. But notice we have 6 red things and 4 blue things, and there was no other colors here. So these 2 events are kind of opposite to each other. We call that complementary to each other. You can't have a blue thing and a red thing at the same time. That is called mutually exclusive. But these are opposites to each other because if you don't pull out a red thing, you're going to pull out a blue thing. So we also call them complementary. We'll talk about that more in the future. All right, what's the probability that we have a rock? Well, there are a total of, there's 3 blue rocks, right? And there's 4 red rocks and 3 blue rocks. And then we have a total sample space of 10 things altogether. So then our probability of getting a rock would be 7 out of 10. And then that doesn't reduce, so we leave it like that. And then the probability of a marble, well, we can list it all. We could say that we have 2 red marbles and 1 blue marble. And then we have 7 rocks and 3 marbles and so on. So we get a probability of 3 out of 10. But again, notice that these 2 events are completely opposite to each other. And if you don't get one of them, you're going to get the other one. You can't pull something out of the bag and get something other than a rock or a marble. So if you don't get a rock, you're going to get a marble. If you don't get a marble, you're going to get a rock. And so as a result of that, we call these complementary. Well, if you notice that complementary events, these 2 events here, they are opposites to each other in the sense that if you don't get one of them, then you will get the remainder of it. So you can see that these two fractions are going to add up to 1. 3/5 plus 2/5 is 5/5 because you're going to get one or the other. So you have a 100% probability of getting either a red thing or a blue thing. Same thing with number 3 and 4. You have a 100% probability of getting a rock or a marble because 7/10 plus 3/10 is 1 out of 1 or 10 out of 10, which is 100%. All right, here's another practice set of problems. So go ahead and pause this. Hopefully you guys understand a deck of cards. If you don't, go find a deck of cards and figure out how it's broken down. But go ahead and pause the video and then come back and see how you did. All right, for this set of problems, it says one card is drawn from a regular deck of cards. So there's a deck of cards has 52 cards in it. There are 4 different suits. There's the clubs, the hearts, the spades, and the diamonds, right? And there are 13 different cards within each suit. So there's ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king in each suit, okay? What is the probability that the card will be a spade? Well, there are 4 suits. So you would say the probability is 1 out of 4 because each suit has the same amount of cards in it. If there were, let's say there were 14 cards in the spades, there was 14 different spades, and then for some reason there was 12 hearts. It wasn't a normal deck of cards. Well, then it wouldn't be a standard probability of saying, okay, it's 1 out of 4. But in this case, there are 13 spades out of a total of 52 cards, which reduces to 1/4. For number 6, it says, what is the probability that the card won't be a spade? Well, if it's not a spade, that means it's something else. Well, there's a total of 39 other cards in this deck, and so we get a probability of 39 out of 52, or 3/4. Now again, these are called complementary events. Complementary events are opposites to each other. So if you say a spade, the opposite of getting a spade is not getting a spade. And so we use that idea of not a lot in probability. Getting something and not getting something, well, you notice that if you get something, it's 1 out of 4 probability. That means you have a 3 out of 4 probability of not getting it. These again are called complementary events. So how is probability of an event occurring and the probability of an event not occurring related? Well, you guessed it, and we already talked about it. The probability of an event occurring plus the probability of that event not occurring is exactly 1, or 100%, or 1 out of 1, or 4 out of 4, or 52 out of 52. The total sample space is filled up by something happening plus something not happening. So that's an important concept, and we can see that 1/4 plus 3/4 is in fact 4/4. All right, these again are called complementary events. Okay, notation-wise, I like this notation. This is a standard notation. The probability of E plus the probability of, what is this? That looks like an exponential thing. No, it's not. It just means the probability of an event not occurring. So if you see this little C up here, that means not. Okay, so the probability of E plus the probability of not E is 1. All right, so let's take a look at another example here. Just a quick one, and dealing with flipping coins. Now we're going to go a little bit deeper, a little bit more difficult into this because we are flipping a coin 3 times. So in part A, what I want you to do real fast, pause the video, list all the possible outcomes of the sample space. So list every possible outcome that you can get. So you're flipping a coin 3 times. I'll help you out here. One possibility is that you get a heads, and a heads. So 3 heads in a row. So you would list that out. A heads, and heads. Go ahead and pause the video and fill out the rest of the possible outcomes that you can get. Okay, so all the possible outcomes, you can get a heads, or a heads, then a tails. then a heads, then a tails, and a heads. You could get a heads, a tails, and a tails. So those are all the options that I can think of, and those are all the options that are if we start off with flipping a heads first. If I start by flipping a tails first, I could get a tails, then a heads, then a heads, a tails, then a heads, then a tails. Or I could get a tails, and a heads, or a tails, and a tails. Okay, so those are all the possible outcomes. Notice there are 8 things in our sample space because you have 8 things that could happen. Now, part B, it says, what is the probability that the coin lands on heads exactly twice? So this is our event space. We want it to land on heads exactly twice. Well, we can see that it lands on heads exactly twice. Well, not here because that's 3 times. It says exactly. So we get 1 here, we get 1 here, and then we get 1 here. So there are 3 places where heads is landed on exactly twice. So the possible event space, the event outcomes, is those 3 things listed out. And then obviously our sample space is all 8 things listed out. And so the probability of exactly 2 heads would be 3 out of 8. For part C, it says, what is the probability that the coin lands on tails at least twice? So at least means that it can land on tails twice, or it could land on tails 3 times. So we can see that it lands on tails twice or 3 times in those 4 places that I've indicated there. And so our event outcomes are those 4 things listed out. All right. And then our sample space, if we're going to list all those out, would be all 8 of these options. But our probability of at least 2 tails is going to be 4 out of 8, which reduces to 1/2. And so that wraps up the lesson for probability of a single event. Make sure that these notes are put together pretty well, and then continue on this assignment, answer the questions below, and see how you end up. And I will talk to you later.